Let's see how to define the parameters related to bar buckling in BIMserver 3D. To do this, we open the bar menu at the top of the interface and click on Buckling. We select the bars by clicking on them one by one or using the crossing method. Then we confirm with the right mouse button. In the window that appears, we assign the buckling length and the moment coefficient in the bar's local XY and XZ planes. To facilitate the identification of these planes, the local coordinate axes of the section are shown in the diagram above, using the same colour coding as in the model. The program allows us to assign the buckling length in the XY plane and in the XZ plane by activating the corresponding checkboxes. Among the available options are the following: do not take buckling into account, beam fixed at both ends, bar simply supported at one end and fixed at the other, simply supported bar, and cantilever bar. In these cases, the program sets a predefined value for the buckling coefficient of 0, 0.5, 0.7, 1 and 2 respectively. By default, the program assigns a buckling coefficient of 1. The next button allows us to enter other buckling coefficient values. For this, we set the buckling coefficient in the field below. This value will multiply the bar length from node to node to obtain the buckling length. We can also assign the buckling length directly instead of using a coefficient. To do this, we select the corresponding icon and enter the length value in the units of measurement defined in the project. The buckling length corresponds to the distance between two consecutive inflection points of the bar's deformed shape. The following button allows an approximate calculation of buckling lengths to be carried out, for which we need to specify whether the structure's type is sway frame or non-sway frame. The validity of this rough analysis is limited to structures that are significantly orthogonal. There are other conditions and limitations for this analysis that can be consulted in the help text that appears when hovering over the option. In the following fields, we can assign a moment coefficient in the XY plane and in the XZ plane by activating the corresponding checkboxes and then entering the equivalent uniform moment factor for both planes. Each code provides values for these coefficients depending on the different bending moment distributions between bracing points. By default, the program uses coefficients that match the unit. We validate the data by clicking Accept. If we zoom in on the bars, the values of the parameters entered for the XY plane and the XZ plane can be seen above them. These parameters are also shown in the dialog box that appears when moving the mouse pointer over the bars in the buckling section. If we haven't assigned a coefficient to the bars when we analyse, a warning indicating this matter will appear. If we continue, it automatically assumes the default values. We finish with a preview of the ULS checks reports in the analysis menu, where we can see that the buckling parameters have a marked incidence in some bar checks. Proof of this can be seen in the resistance to axial compression and combined bending and axial resistance checks. The ULS checks vary depending on the selected code.